15 meters wide in a completely dark room. And you're holding a small but very bright light bulb, 3.4 millimeters across. And you were holding it about 31 centimeters above the table. What you'd see is a circular pool of light directly on the table, beneath the light bulb. But on the other side of the table, it would be in darkness. Now, it seems to our mind that if you were on the other side of the table, you would see the light because it's, above the table. But that's not true, because on that part of the table, it's in darkness, meaning that the light isn't physically reaching that part of the tabletop.
Your senses are correct.
We're also told that the sun sets because as the Earth rotates us away from the sun, it's actually obscured by the physical curvature of the Earth. That's not what we see.
What we see is a local sun that is taking its local light with it. What happened to the horizon glowing across half of the world? Most sunsets are already fading through pollution, dander, chemtrails, and fog. Plus, refraction will always make the sun seem like it's going down, as well as your perspective.
It would appear to sink down in your field of view. That's perspective. The further away you get from it, the lower it will appear. It doesn't physically change its height, it just appears that way to your eyes, until eventually it will disappear behind the horizon formed by your eye's vanishing point. Your eye has an angular resolution of 0.2 degrees, and anything at that height will disappear beyond the limit of your sight. Many times we can see time-lapse footage of the sun that shows it getting smaller as it moves away from us. Now, that's not always the case, since the sun is travelling around the North Pole. The closer you are to the north, the less you'll see the size change. But from locations beyond the equator, you'll absolutely see the sun's size change. And that could never ever happen if the sun was 93 million miles away. You wouldn't see the sun change at all.
Our eyes cannot see farther than what they were designed to see, but that is no reason to keep them closed.
There's also an effect that occurs under certain conditions called atmospheric lensing, where the sheer amount of atmosphere, as well as the rain between you and the sun, acts like a lens and a prism, magnifying it greatly, which leads to another observational proof that the sun setting is an optical effect.